Okay. So if all three delays are specified, they refers to the what? See, the turn-off delay is the what? Minimum of two delays. When two delays are specified, the turn-off delay should be what? Minimum of two delays which is specified. Did you understand? If all three delays are specified, they refers to what? Rise, fall, and turn-off delays. If there is no delays are specified, by default, what is the value of the delay will be 0. So until now, whatever the gate level modeling technique we write using primitive gates, all these are without delays. Did you understand? Let us see the example to this. So delay of the delay time for all the transitions. Only one delay is specified here. This AND is nothing but what? What is AND is here? Primitive gate. Followed by what is this is nothing but delay. As delay, and this is nothing but what? A1 is nothing but instance name, output, out, and input are what? I1 and I2. So rise and fall delay specification. So if I'm writing like this, and hash 5, delay I'm giving 5, then instance name followed by output and input. Output and input. So this is specification for what? For all delays. Rise delay is how much? 5. Fall delay how much? 5. What is turn off delay? How much it is? Minimum means 5 means minimum is nothing but 5. Minimum of two values, two delays. That is minimum value here. It is nothing but 5. If only single delay is specified, this is corresponding to what? The delay for all the transitions. Did you understand this? If two delays are specified like this, this is a rise delay, this is corresponding to rise delay, and this is corresponding to the turn off delay. Then what is the fall delay? What is the turn off value is? Minimum of this. Suppose if I am writing add hash 3, 5. So A2, this is the output, I1, I2. So what is the rise delay is? 3. What is fall delay is? 5. What is the turn off delay in this case? If two delays are specified, minimum of these two. What is the minimum of these two is nothing but 3. So in this case, turn off delay is 3. Rise delay is 3. Fall delay is 3 and turn off delay is nothing but 3. So this is an example you can see. So this is a third one. This is an example for rise, fall and the turn off delay. So we are specifying all the three delays here. Rise delay, fall delay and the turn off delay. So this is the first example is and hash 5 means delay of all 5 for all the transitions. 3. Hash 4, 6 means what? Rise delay is 4, fall delay is 6, and then what is turn off delay is nothing but 4. And this is another case where all three delays are specified here. So then this is a rise delay, this is a fall delay, this is the turn off delay. Did you understand? What are the delays which is associated with the primitive gates? Rise delay, fall delay. Okay. So you can also specify the delay for the rise, fall, and then turn off delay with using minimum, typical, and maximum values. You can mention what is the minimum value of the rise delay, what could be the typical value of the rise delay, what could be the maximum value of the rise delay. Okay, in previous case we are writing like this. Hash 5 means what? This is a delay for all. For all means what? Rise delay, fall delay, and turn off delay. Now you can specify this using what? To modify your gate operation to check the delays, you can specify the minimum. What is the minimum for the rise? What is the typical value for the rise? What is the maximum value of the rise? You can bound the value between minimum to maximum and then typical value. Okay, so this is the another one. So Verilog provides additional level of controlling of this rise delay, fall delay, and turn off delay. So level of control for each type of the delay mentioned above, like rise delay, fall delay, and the turn off delay. So for each type of the delay, that is rise, fall, and turn off, three values you can give. What are the three values is? You can give the minimum value, you can give the typical value, you can give the maximum value can be specified. So any one value can be chosen at the start of the simulation. Okay, when you are simulating with the different delays, any one value can be selected. Minimum value, typical value, or maximum value. So minimum, typical, maximum values are used to model the device whose delays vary within the minimum and maximum range because of this IC fabrication process variations. So I want to check the gate of performance, some sort of performance I want to do with the delay specifications. So I can use this minimum, maximum, typical minimum value, typical value, and the maximum value to model the device with the various delay process during the IC fabrication process. So this minimum, typical, maximum value you can specify during the runtime to check for the this typical value or minimum value, maximum value, what is my performance of the gate. Okay, so with the delays process to understanding this, you can mention the minimum, typical, and the maximum values. So these are you can specify what you can specify the rise time with what minimum, maximum, and typical. Fall time also minimum, maximum, typical. Then turn off also minimum, maximum, and typical. So what is the minimum value means? The minimum value is the minimum delay value that is designer expect to give to the gate. In typical values also, the typical value, delay value that designer expects to give to the gate, and maximum value also, it is a maximum delay value that designer expect to give to the gate. Did you understand? So this is a minimum, typical, minimum, and max value. So minimum, typical, max values are chosen during the runtime. So when you are running the runtime during the runtime of the program, you can choose the values of what? Minimum value of the rise time, maximum value of the rise time, or typical value of the rise time. So the method of choosing the minimum, maximum time, the values may be vary for the different simulator. Okay. So basically this is value when you are passing during the runtime. So in our case, we'll be using this the system task function means dollar symbol value, dollar symbol plus arcs, plus arcs. So this is like your scanf in your C program. So what is the use of the scanf? It is to read the input from the one user. User is from the if you want to read the input from the user, we'll be using scanf, right? So here I'm using what is the system task function is nothing but dollar symbol value, dollar symbol plus arcs. So this is used to take the input from the way from the user during the what? Runtime of your program. So when you are mentioning the minimum type and maximum values, so this method of choosing the minimum, typical, and maximum value may vary for the different simulator or different operating system. Okay, so for Verilog, the values are chosen by specifying the options. So how you can pass this value is you can start with the in your run.do file. You should pass the arguments to your test bench file. So using plus, we'll see what is the use of this system task function in the later sessions. How you can use, how you can give the input from the user during the runtime. Okay, so plus and then you specify the maximum value, plus specify the typical value, plus specify the minimum value during the runtime. During the runtime, if no options is specified, the typical delay value is by default. It will take the typical value. Okay. So this allows the designer the flexibility of building the three delay values for the each transition into their design. So during the runtime, I'm going to specify all these delays and I'm going to check the functionality. So this gives me the flexibility of building the three delays values. Okay, so the designer can experiment with the delay without modifying the design. So what is the use of this is nothing but min, typical, and maximum values. This can be given at the during the runtime. What is the use of this is nothing but designer can experiment with the different delays without changing, modifying the one my original design. So by changing this minimum value, typical value, and maximum value, you can experiment with the various delays to the gates. Did you understand? So these are the delays which is specifying another way to controlling the delays of your gates is nothing but using minimum, typical, and the maximum value. So how you can specify this minimum and maximum typical value? Let us take this example. So this is an example for minimum max typical delays. So one delay. So if plus minimum delay, if you are giving this is 4 and typical delay is 5 and maximum delay is 6, how you can specify this delay in your primitive gate? This is 4. You can give. Earlier we used to do like this, right? If I'm going to give hash 5, this is rise delay, fall delay, and turn off delay. This delay can also specified with another way you can control using giving the minimum value, giving the typical value, giving the maximum value. So this is a one example. You can see and is a primitive gate as followed by the delay. The delay is specified with respect to what? Minimum, maximum, and the typical rate. What is a 4 colon 5 colon 6 means? This is for what? As by I am giving. As by means this is for all delays. All delays means what? Rise delay, fall delay, and turn off delay. In rise delay, what is the minimum values? 4. What is the maximum values? Maximum value 6. What is the typical values? 5. This is same for what? Rise, fall, and the turn off delay. Since I am specifying what? Only one delay. Correct? Now, if there are two delays are specified like this, this is for rise, correct? This for a rise for what? Minimum, typical, maximum. This is for what? Fall, minimum, typical, maximum. If two delays are specified, what about the turn off delay? The minimum of the minimum of the typical, minimum of the turn off. So what is the minimum of this? Minimum of this is nothing but 3 comma 5, right? This is 3 and this is 5 here. So what is turn off delay then here? Hash 3, correct, colon. And what is the minimum of 4 and 6? Typical values 4, correct. What is the minimum value of 5 and 7 is 5. So this is the delay, minimum, typical, and maximum for what? What is this is for? Turn off delay. Did you understand? If two delays are specified. If I am specifying the 3 delays here, this is for what? Rise delay. This is for what? Fall delay. This is what? For what? Turn off delay. Did you understand how to specify the delays to the primitive gates? Rise delay, fall delay, and turn off delay. All this will be having one more control. Control way you can controlling the delays using typical, minimum, typical, and the maximum. So these values are selected during the runtime. Correct. So without modifying your original design file, you can experiment with the gate by changing during the runtime of the program. So these are the delays which is associated with the primitive gates. Are you understand? Now let us take an example to work with these delays. Okay. So to work with this delay, now let us take this example. So how many gates are there here? 2 gates. This is AND gate. This is OR gate. So what is the delay I have given to this is nothing but hash 5. So what is this hash 5 will tell us that? Only one delay I am giving. Correct. So this is rise time, fall time, and the turn off delay. So single one I am giving. So what is the output of this is nothing but output is E is nothing but what? A into B. Correct. A into B plus C. Now can you write a program to this? Write a gate level program to with the delay associated with this which is specified. So write a program to this. This is a program to this is module, correct? Module. So let us take delay. Module name is delay. So what are the inputs and outputs is output. So A comma B comma C. So what are the inputs here? A comma B comma C. Input is A comma B comma C. Output is out. So there is a wire. There is an intermediate connections with the wire is E. Correct. Now can you write the delay associated with this? What is the delay associated with the AND is? How to write? Use the primitive gate. Correct. 5 is the delay, followed by what? Gate name. Did you understand? Now, what is the output to this is nothing but E, A cover. Again, another gate is R. What is the gate delay associated with this is nothing but 4. Gate 2, correct. Out comma. This is B comma, E comma C. Then end the module. End the module. So when E will changes, if you give the inputs A and B, A, B, C are the input to this, E will changes. When E will changes after 5 time delay, because you are giving what delay here. Did you understand? When this output will changes after 9. So first gate is nothing but 5. Second gate is nothing but 4. So output will get after what delay? 9 delay. Did you understand? So this is the test module to this, design file to this. So module D, output ABC, port declaration, internal wire is E, correct? Then we are instantiate the primitive gate using the what? Delay of how much for this AND gate is 5 delay. R gate is how much delay it is? 5 delay, correct? Sorry, R gate is 4 delay. Now this is the test bench to this. So you know how to render test bench, correct? So this is a module stimulus, reg R ABC, wire is out. So we are instantiating the module D. Module name is D here. Now we are initial begin. So we are assigning the value to ABC. ABC, A is 0, B is 0, C is 0. At what time this is nothing? At time t is equal to 0. Is it correct? At time t is equal to 10, what we are giving? A is 1, B is 1, C is 1. At a time, what is this time is nothing but 20. 10 plus 10 is 20. At time 20, what is the A value is? 1, B value is 0, C value is 0. Correct? Then we are finishing. At what time? So this is 10 plus 10 is here, up to here it is nothing but what? 20. So 20 plus 20 means what? At 40 we are finished. So we are in this initial begin, we are in the module. Analyze this program. You can see this program. This is a waveform. So this is time at t is equal to, this is time at t is equal to what? T is equal to 0, t is equal to 10. At the time t is equal to 20. So at the time t is equal to 40, we are finishing this. Right. At time t is equal to 0, what is my A values? 0. What is my B values? What is my C values? 0. But AB output will changes after what? E will. E is the output, right? E is the output of 1 gate. E will changes at what delay? At 5 delay. So this is a 5 delay. Now E becomes what? 0. Correct? A is 0, B is 0, and operation of output is nothing but what? E is 0. So E will get after what delay? 5 delay. And then output will delay how much? Now this is up to 5. This is nothing but what? 9. So output changes. A is 0, B 0, C 0. AB will get after 5 delay. Output AB output will get after 5 delay. And R output will get after how much delay? 4 delay. Total how much delay it is? 0 to 9. Then I am getting output is 0. Do you understand? Now we are changing the values of ABC at the time t is equal to 10. At t is equal to 10, what is my A is? 1. What is my B is? What is C is? 1. But during this 5 delay, what is my output I am getting is 0. Why I am getting 0? It is AB will delay by how much? How much delay? 5. And then R gate will delay how much? 4. So therefore, I will be getting output of this at this here after 5 plus 4, 9 delay. Correct? So until this, I will be getting 0 here. Here also 0. Then after the 9 delay, I will be getting this. Did you understand? See, okay. Let us see this. What is the delay of the AB is 5. C is nothing but 4. So at time T0, we are giving A0, B0. A0, B0. Is it immediately output will changes? No. Because delay associated with AND gate is nothing but what? 5. So after 5 delay, my E will be 0. Correct? Then what is the delay of the OR gate is 4. After 9 delay, this is up to here it is 5, I am getting unknown. Correct. Then after 4, I will be getting what? 0. This result 0, 0, 0, 0 is nothing but 0. 0 under operation of 0 is nothing but 0. 0 under operation of 0 is nothing but 0. Again 0 R operation of 0 is nothing but 0. So this I will be getting after what delay? 9 delay. 1 on AND gate is 5 delay, OR gate is 4 delay. So 5 plus 4 is nothing but 9. After 9 I am getting this. Now I am changing at time t is equal to 10. At t is equal to 10, what I am changing? A is equal to 1, B is equal to 1 and C is equal to 1. C is equal to 1. So what is the delay of this is nothing but? Now what is the E output it should be? Now I am giving A1 and B1, but that will changes after what? After 5. It is changing after 5. Correct? Now A is 1, B is 1 means 1 and with 1 is nothing but 1. This is changing at after 5. Correct? Did you understand this? Now coming to this E. What is E is nothing but? Now A and B is nothing but 1, 1. E is nothing but E is nothing but no 1. So C is also 1. R operation. E plus 1 is nothing but what? 1. So this will changes here. Output is 1 here. Are you understand? Now I am changing at T is equal to 20, E is equal to 1, B is equal to 0, C is equal to 0. C is equal to 0. Again, I am changing the inputs here. At time T is equal to 20. So A will delay how much delay? 5. And then E output will delay how much it is? OR gate is 4. Then output changes after this delay. Did you understand? So this is how you can associate the delay with the. Okay, let us run this and yeah.
Here at the input, when all the inputs are 1, after getting E only, you will get the output out. So after 5 minutes here, after 5 minutes delay of, again 4 minutes delay. After that, we should get the out.
See, at the time T is equal to 0, I'm changing A, B, C. A is 1, B is 1 and C is 1. Correct. But E will changes after 5 delay. Correct.
After getting E only, we get the output out. E and C will give out.
Yes, that is what here. This is a delay of the output 4. Output 4. This is a delay of the output 4. You can see it is changing after 4 only. Okay, let us do one thing. Let me run this and show the timing diagram. Okay, same program. Let us open this. This is my test bench. This is a program we have written. Now, what is the delay? For the moment, let us remove this. What is the delay we have given is? AND gate is 5 delay. OR gate is how much? 4. This is the design file. Let us save this. Now coming to the test bench. You can see the test bench, the JBC, correct? So I'm monitoring this, I'm instantiating the delay D here. Now at time T is equal to 0, what is my A is? 0, B is 0, C is 0. At time 10, A is 1, B is 1, C is 1. At next time, what is this? At time 20. At time 20, correct? What is my A is? 1, B is 0, C is 0. Then I'm finishing at time 20. Then end the module, end the initial region. Now let us run this program. folder. Let us close this. So this is the A. Let me take this out. So this is A, this is B, this is C, this is E, and this is E and out. So at time t is equal to 0, correct? This at time t is equal to 0, A is 0, B is 0, C is 0. So this AB will changes after what time delay? 5. After 5, this becomes 0. Until that, what is this is nothing but unknown. And this output will changes after what delay? After 9 delay. Now it is changing after 9 delay. Correct. This is output 1. A0, B0, C0 means output is 0. Correct. So again, at time t is equal to 10, what I am doing here is A is equal to 1, B is equal to 1, and C is equal to 1. So this output will be there. How much time here? This output will be there up to 1. Is it 14 or 15? Now this is delayed how much? Output is delayed by how much? 9. Correct. From year to year, what is this delay is? This is 9 minus 14. 5. Correct. Now, see, you can see at time t is equal to 10, A is 1, B is 1, and C is 1. But A will be delayed by how much here? This is at time t10. A is delayed by how much? 5. Correct. Again, at the time 20, we are making A is equal to 1, B is equal to 0, C is equal to 0. So, first, okay, let us understand the E, then we'll go for the out. So, E is changing at what time? 5. Correct here. Again, at time t is equal to 0, A changes, B changes, and C changes, but E changes at what time? 15. Correct, after 5. Again, at time 20, what is my A is? 1 and B is 0. But E will changes after what time? 25 time. At 25, E should be 1 or 0. At time 20, A is 1, B is 0. What is under operation of 1 into 0 means? 0. This is changing at what time? At 25 time. Did you understand? Are you clear? So I am talking about, okay, let us take this E output, right? E should become as drag this in. For the moment, you forget about C and output. So this is my A and B. A and B. A0, B0. So delay is 5. So that until the 5 timestamp unknown. E changes at what time? 5. Did you understand? Now coming to a time t is equal to 10, what is my AB values? 1, 1. 1, 1 means under operation is output is 1. But this is changing at what time? It is changing the 15. What is the delay associated with this? 5. Again at time t is equal to 20, what is my A is? A is 1. What is my B is? B is 0. Correct. A0, B0 means what is under operation is? 0. This is changing at what time? 25 time. This is the delay associated with the what? AND gate. Now coming to the OR gate. A0, B0. This delay of this is nothing but 5. And delay of the OR gate is nothing but 1. 4. 5 plus 4 is nothing but 9. The output changes at what time? 9. Did you understand? This delay will be there for next 5 times. Next Is it 4 time or 5 time? So this is changing at 5. The delay associated with the AND gate is nothing but 5. Correct. Now after this 5, this becomes what? 1. Correct. Now what is the output of this out? Here C becomes 1. Here C becomes 1. Correct. When C becomes 1, what is the output? Output should. See in this case, when T is equal to 0, what is A is 1. What is B is 1. What is C is also. C is also 1, right? C is also 1 at time T is equal to 10. When C is 1, what is the delay of the OR gate is? 4. Therefore, C plus, what is the gate is nothing but C plus E. What is C plus E? E, irrespective of the E, when C becomes 1, this is changing at what time? 4, delay of 4. Now output becomes 1 after the 4. You can see this is 10. This is nothing but what? 14. After 4 delay, C becomes 1. 1. Since C is equal to our time T is equal to 10, I am making C is equal to 1. 1. After delay of 4, C becomes 1. Are you understanding? Let me clarify this. This is a circuit we have, correct? This is the AND gate with the hash 5 delay. This is the OR gate. This is the OR gate. This is the output. This is C, A, B. What is the delay of this is nothing but 4. This AND gate will be delayed by how much? 5. This is the input E. Correct. So at time T is equal to 0, what I am doing? A is equal to 0, B is equal to 0, C is equal to 0. E becomes 0 after what delay? 5 delay. Until that, what is the E value will be? X. Unknown. Correct? For this input, A0, B0, C0. What is the C output? This is E. What is the output? When output will get 0? After what? 9, correct? This is delay of this is nothing but 4. For A is equal to 0, B is equal to 0, C is equal to 0. After 5 delay, E becomes 1? 0. Again, after 9 delay, what is C out is? 0. After 9, I will be getting what? Out is equal to 0. Correct? This is I am giving at what time stamp? T is equal to 0. Correct? Now at the T is equal to 10, at T is equal to 10, so what input I am giving is? This is 1, 1, 1. Correct? So at E will changes after what time? E becomes 1. When this is for a time T is equal to 10, what is A is I am giving is? A is 1, B is 1, C is 1. So E will changes to 1 after what delay? 5 delay. Correct? Means this will changes at what? Exact time. For T is equal to 10 means at what time it is? 15. This is changing at the 15. It is changing at the 15. Correct. Now coming to this out. What is this out is? At T is equal to 10. Now this input is also 1, right? This input is also 1, irrespective of this E input. Correct? So this is changing at the 9. At 9 plus 4 means what? 14. At 14 E becomes what? 1. Because this C in is nothing but what? 1 here. You don't understand, irrespective of this. It is 19. See when at time T is equal to 0, E changes after 5. For this input, A0, B0, C0. and E changes for this input 9. Now at time t is equal to 10, I am keeping what? A is 1, B is 1, C is 1. So this will changes after what time? 15. After 15, E becomes 1. Since this input is 1 here, correct? This input is 1 irrespective of this. This is changing at output is 0 at 9. This is becomes 1 at what time? 4. 9 plus 4 means how much? 9 plus 4. Now this is changing at after 9, right? After 9. Output becomes 0 after 9. Correct? Now you can see this diagram. This at what time at? 9. Output becomes 0. Now this is becomes 1 after what time? After 14. Correct? What is the delay is? 1. How much delay it is? This is 14 minus 9 means how much? 14 minus 9. 5 delay. Correct? After 5 delay, this output becomes 1. Since C is equal to 1. Did you understand now? Now you can see this will be same from this input. Now at time t is equal to 20, what is my A is? At t is equal to 20, what is A is? So let me write at t is equal to 20. At t is equal to 20, what is A is? 1. What is B is? What is C is? 0. So the output of this AND gate will changes after what delay? 5 delay. Correct? Now you can see this is the A is 1 and B is 0. This is changing after what delay? 25. This is changing at the 25. Correct? Then E will changes at what delay? 25. 25 plus 4 means what? 29. This is changing at the 29. Did you understand? So this is the delay which is associated with this. Let's copy this in new slide. Now you can understand this diagram. So this is changing at what delay? E is changing at after 5 delay. But this A0, B0, C0. And then output will changes after what delay? 9 delay. Becomes 0. So during this, E is nothing but 0. At time t is equal to 10, this is 1 and this is 1 and this is 1. A is changing at what delay? 5. Since this is C is equal to 1, after 4 delay, out becomes 1. Did you understand? Then it follows because ABC is 1, 1, 1. Now coming to this time, t is equal to 20. What is A is 1. What is B is 0. So therefore, E will changes at what time? After 5 time. Correct? This became 0. Then E, this is 1, 0. Again, this will output will changes after what delay? 4 delay. So it is changing at what time? At time 29. So this is nothing but 20 plus 5 means 25 plus 4 means 29. Output will changes at 29. Did you understand? So if I am specifying delay like this, let us specify the delay like this. So this is for what? Only single delay. Single delay is for what? Rise, fall and the turn off delay. Now I am going to specify like this. What is this is nothing but? Rise and fall delay. So rise and fall delay. Now let us run this. Now can you analyze this? How rise delay, fall delay is happening. This is the output. Let me drag this last. And this is the output. Can I analyze this rise delay, fall delay for this one? So here A is 0, B is 0. Same input I am giving. At time t0, A0, B0, C0. At time t is equal to 10, A is 1, B is 1, C is 1. At time t is equal to 20, A is 1, B is 0, C is 0. Now this will change us. Where is my E? E will change us after what time? But what time it has to change? What is the fault delay I am giving is? What is the fault delay is? 5, 1. Rise time is 5 and fall time is 1. 1. And then next gate, OR gate, rise time is 4 and fall time is 1. Now can you analyze this one? Now time t is equal to 0, what is this is? What is A, B, C value is? A is 0, B is 0. Now at what delay it is changing to 1? Fall. Fall is happening at what delay? At 1. Correct. Now rise should be happen. Now my this is C is also 0. This is happening at what? Here also fall is happening at what time? Fall is happening at what time in the output? See, okay, coming to this program, what is fall time I have given is 1 and OR gate. This fall time is what? 2. 1 plus 2. Earlier rise is happening at what time? 5 and 9, correct? 9. Here fall should be happen at what? First AND gate is at 1. Second OR gate is happening at what time? 1 plus 2 means what? 3. So fall is happening at what? 3. You can insert the 3. Did you understand? So I am giving here 5, 1 and 4, 2, 5 for the rise and 1 for the fall. So fall should be happen at what? For the AND gate is 1. And second OR gate it should be 1. 2. So 1 plus 2 is nothing but 3. Right? So fall should be happen at the 3. Now after this, what is my output is 0. So I am included with the rise time and the fall time. Okay. Now at time t is equal to 10. At time t is equal to 10, what is my ABC is nothing but 0. Sorry, 1. A is 1, B is 1 and C is 1. Now it should happen at what time it should happen? E should be changed at what time? Rise time. Rise time should happen at what? 15. You can see this E is changing at what time? 15. Because what is rise delay I have given is 5. Correct. So here E is changing because C is 1. E is changing at what? 14. Did you understand this one? Rise time and the fall time. Now again, at time t is equal to 20, A is 1, B is 0, C is 0. Okay, fall time should happen at what time? When A is 1 and B is 0 means output is 0, means it is falling. AND gate output will be 0 means what? Falling. At what time it should fall? What is the delay of this is nothing but 1. Now time t is equal to 20, I am making A is 1 and B is 0. So that it is fall is happening at what time? 21. Correct? Again, what is the output when it is changing? What is the fall delay I have given this? 2. So 1 plus 2 means 23. At 23 it should fall. You can set 23 it is falling. You need to understand how to introduce the rise delay and the fall delay. Now if I am going to include with this one more delay, then what that becomes is turn off delay. So if I am going to write like this is 5, 4. Again, this is nothing but 5. What is this turn off delay is nothing but? When you will get what is the rise delay is? Whenever it is taking the transition from what to what? 0 XOR is equal to 1. Fall time means 1 X is equal to 0. That is a fall time. What is turn off time delay is? 1 0 X to the result. So in our case, there is no time delay, like it is changing from what? 1 x 0 to the z. In that case, you can go with what? Turn-off delay, including the turn-off delay here. Did you understand? So these delays also can be given when? What is this delay is nothing but you can give the rise time, fall time, and then turn-off delay using another way of you can control the rise time, fall time, and the turn-off time using what? Minimum gap value, typical value, and the maximum. So that values you can view during the runtime. Did you understand? Now you see in this simulator, I can able to show you the two delays. One is rise delay and the fall delay. So whenever your transition happens from one x